Hi to everybody, and I welcome to today's lecture. In today's lecture, we are going to study about the DFT meat, that is dark, firm, dry meat. It is also called as dark cutting in beef, or it is called as glazy bacon in the case of pigs or the pork. So in the previous lectures, that is in the module conversion of muscle to meat, in lecture 1, we have seen that how the glycogen is getting converted into lactic acids. That is, during the anaerobic glycolysis, the glycogen storage in the muscle will be getting converted into lactic acid. So let's just brush up what we have studied in that lecture. And I also request you to go through that lecture, and then if you come to this lecture, it will be more useful. That is conversion of muscle to meat, lecture 1. You hear that lecture first, and then you can come to this lecture that is on DFT, which will help you to understand better. So in short, let me brush up what we have studied in the previous lecture. So when we know that in the muscle, the energy is stored in the form of glycogen. So during the anaerobic glycolysis, the glycogen will be converted into lactic acids. If the glycogen content is more, the quantity of lactic acid formed will be higher. In the case of normal muscle, the glycogen content will be normally 1%. And when it is during the conversion of muscle to meat in the normal muscle, the concentration of the lactic acid rises from 0.05% to 0.5 or 1%. So this lactic acid formation, along with the accumulation of H plus from the lactate and ATP hydrolysis, account for the pH decline in the muscle during the conversion of muscle to meat. This we have already seen in the previous lecture of conversion of muscle to meat. With this background, let's enter into today's topic, that is DFT meat. So DFT meat is also called as dark cutting beef or glazy bacon in the case of pigs. So DFT means it is dark, F stand for the firm, and D again stand for the dry. So why this occurs, or why this condition is seen? When you put the animal under long duration of stress, I repeat, long duration of stress before slaughter, then we can come across this type of conditions. So DFT meat is found in carcass from animals which before slaughter have undergone prolonged muscular activities. So if you put the animal under more muscular activities without proper feeding, or when you put the animal before slaughter for a long duration of stress, we can come across this DFT condition. This is mainly seen in the case of beef and pork, where the glycogen resource is depleted to a great extent before slaughter. So when the glycogen resource is not sufficient, the ultimate pH formed in the muscle will be high. So it can lead to a condition called as dark, firm, and dry. So here you can see the attractive, the blue, this is the normal meat, and here we can see the unattractive color of the meat, which is the DFT meat. So what are the factors that is leading to DFT? So there are many factors which can lead to the dark, firm, and dry meat. This is mainly seen in the animals which are put under long transportation without adequate food and rest. So you are transporting the animal for a long duration without the food and without adequate rest. That can lead to dark, firm and dry meat. Extended period without food. We are putting the animal under long duration of starvation before slaughter can also lead to DFT condition. And the third factor is the beating of the animal, kicking of the animal, howling at the animal, making loud noise. This will all put in the fright, and it can lead to the release of adrenaline, which will also in turn results in the reduction in the glycogen. And fourth is long physical exertions, that is the stress. When you put on the long stress also, it can lead to DFT. Exposure to the extreme temperature. So within the day, if there is a much variation in the temperature, can also bring stress to the animal. And if the temperature is above 30 degrees centigrade, again it can lead to stress on the animal. Or within the day, if the temperature variation is more than 5.5 degrees centigrade, then also it can lead to stress on the animal, which in turn can lead to DFT. Then the bull expressing the sexual behavior and the efforts in estrus and the hormonal treatments like estrogen implants or steroid treated with the testosterone. These conditions can also lead to DFT. And the last is the mixing of unfamiliar animals, especially 24 hours to 48 hours before slaughter, can also lead to the dark cutters. So these are the main factors which can lead to the DFT condition. In all, I can say the long duration of stress before slaughter can lead to DFT conditions. So what is happening in the DFT, or how it is occurring? So before understanding the DFT, let's understand what is happening in the normal muscle. So you know that in the normal muscle, before slaughter, the pH is around 7 or 7.1. So once the animal is slaughtered, there's a shifting from the aerobic glycolysis to the anaerobic glycolysis, which we have seen already in the lectures, conversion of muscle to meat. So during this shifting, or during the anaerobic glycolysis, the glycogen resource, that is, you know that in the animal body, the energy is stored in the form of glycogen. This glycogen will be converted into lactic acids, and there is an accumulation of H plus ion also from the lactate, which reduce the pH of the muscle. So in the ultimate pH, so from 7 or 7.5, it will attain an ultimate pH of 5.4 or 5.6. In this, I'm talking about in the normal meat, where the glycogen content will be approximately 1%. So what is happening in the DFT? I told that when you put the animal under long duration of stress, naturally the glycogen resource will be less. Since the glycogen resource is less, the ultimate pH formed will be less, or rather it will be more than 6.3, or it will be in the range of 6 to 6.5 or 6.6 like, because the glycogen resource is less. Why the glycogen resource is less? Because when you are putting under long duration of stress before slaughter, so naturally the accumulation of lactic acids will be less. So let's see step by step what is happening here. So because of the stress or long duration of stress, there is a depletion of glycogen from the muscle stores prior to the slaughter. Since the glycogen store is less, there's a reduce of the substrate available for the anaerobic glycolysis during the postmortem. So the glycogen is less, that is the substrate is less. So during the anaerobic glycolysis, the lactic acid formation will be less. Since the lactic acid formation is less, so naturally the pH is more than 6, or it will be around 6.3 or 6.4 like. That is the ultimate pH I'm talking. Okay. And this, because of the higher pH of this meat or this muscle, will result in a dark, and the surface will be dry, and it will have a firm texture. So here we can see here the muscle, normal muscle and dark muscles. So in the normal muscle, before slaughter, the glycogen content is approximately 1%, but in the DFT, it is around 0.3%. So in the glycogen, after 24 hours, the study shows it's 0.1%. Here it is 0.1%. The lactate production is high, so we attain ultimate pH of 5.6. Here the lactate production is low, and the ultimate pH will be around 6 to 6.5. So here you can find the ultimate pH is very high compared to the normal muscles, where the ultimate pH will be around 5.4 to 5.6. So let's see what's the difference between the dark cutter and the normal. So here you can see this is the ribeye area. So you know what is ribeye area? It is the area between the 11th and the 12th and the 13th ribs. In the case of cattle, that is the longissimus dorsi muscle. This is the longest healthy muscles. You can see this is bright red in color in the case of normal. In the case of DFT, it is dark purple to almost black in color. The people generally prefer the red color or the cherry red color, which is called as the bloom. The dark color is not normally preferred by the consumers. So let's see why the consumer reject the DFT meat. As already discussed, the color is very dark in color, so the consumer think it is an old meat. But in the case of normal meat, it will have a cherry red color, which is very attractive, and it increases the appetite and stimulate them to purchase. So this cherry red color is called as the bloom. Then coming to the flavor, it will have some syrupy flavor or the musty flavors, again which is not preferred by the consumer. And third is, this type of meat or the DFT meat will spoil faster compared to the normal meat. So people perceive that it is from the old meat or the meat from a poorly handled animal. And the last, it is not suitable for curing. So we will be seeing all these things in the coming slide. Why dark cutting is a concern for industry? One is, already I told you, it reduces the carcass value because of its dark color. It is not preferred by the consumer. It is graded a very low in international market because of the poor consumer appeal. And the third is, its spoilage is faster, especially in vacuumed packed conditions. So we know that when we go with the bulk packaging during the transportation in the sea roads, we generally go with vacuum packaging. So if it is a DFT meat, it will spoil faster. And fourth, it occurs in clusters. So for example, in a particular shipment, or when you get an animal from a particular farm, a large number of animals may be affected. So it occurs in clusters. So naturally, that is going to give a loss for the processors. So that is why it is a concern for the meat industry. So why it is dark? So in the case of DFT, as we already discussed, so why the DFT meat is dark in color? So I told you in this, the deoxymyoglobin is a dominating pigment. So we have the oxymyoglobin. The oxymyoglobin, it is when the oxygen combined with the myoglobin, it forms oxymyoglobin, which gives a cherry red color or the bloom, which is very attractive for the consumer. On the other hand, it gives a dark color. So which is in the case of DFT, which is not preferred by the consumer. So the color of the meat depends upon to the extent to which the myoglobin is oxygenated. Why the oxygenation is not taking place? Let's see. At high pH, the surveying activity of the cytochrome enzymes will be greater. So the enzymes, the cytochrome enzymes will be more active at high pH, say around 6.3 or 6.4 or 6.6 like. In that pH, the cytochrome enzymes will be more active and they will be utilizing the oxygen. So they make, or rather, there is less availability of oxygen to combine with the myoglobin. And most of the oxygen that is carried, or the myoglobin carries oxygen to the electron transport chain, so less oxygen is there for the myoglobin to form the oxymyoglobin, which in turn give the blue or the cherry red color. So most of the oxygen that comes here is utilized by the cytochrome enzymes. So the oxygen availability for the myoglobin to combine with the oxygens will be reduced. And next is at high ultimate pH, what happens is the water holding capacity is high. At high ultimate pH of the muscle, the water holding capacity is high. Since it is having more water holding capacity, the muscle fibers are swollen and the fibers are tightly packed together. Since there is very less space between the muscle fibers, because it is holding more water and it will be in the swollen conditions. So it will not able to scatter much light. Next is the surface is dry, which prevents the penetration of oxygen and combines with the myoglobin. Since it is dry, the oxygen penetration will be very less. Since the structures are swollen, the penetration, there is no much space for the oxygen to penetrate. So the deeper muscles will be darker in color because of the less penetration of the oxygen. So why it is dark in color? The three things is that. One is the enzymes, the cytochrome enzymes are more active. So they will be utilizing most of the oxygen. So the oxygen availability for the myoglobin to form oxymyoglobin will be less. Next is, since it is high pH, the water holding capacity will be more, or most of the water will be bound with the muscle fibers. So naturally it will be more swollen. So there is less space for the oxygen to enter. So again, it will be not forming the oxymyoglobin. And third is, since it is having a very intact and very tightly packed structure, the penetration of the oxygen will be less. So it cannot combine with the myoglobin to form oxymyoglobin, which gives the red cherry color, cherry red color. So let's see what's the relationship between the DFT and the water holding capacity. So we know that the muscle, in the muscle structure we have already seen, in the lecture of muscle structure we have already seen, the muscle is made up of muscle fibers. So this is the muscle fibers we can say. This is one muscle fibers we can say. And each muscle fibers is made up of myofibrils. So this is one muscle fiber. It's just made up of myofibrils. And each myofibrils is made up of myofilaments, that is the actin and myosin. So water is normally held in the myofibrils in the space between the filaments. So you know that myofilaments, in the space between the myofilaments, the water will be held, or it is also held between the myofibrils. So not only between the myofilaments, it is also held between the myofibrils in the intercellular space. So it is held in the between the myofilaments. Myofilaments, it is also held between the myofibrils in the intercellular space. It is also found in the interfascicular space. So this is a fasciculae. So we know that large number of fasciculae form the muscles. Okay. So between this fasciculae, interfascicular space, we can find the water. So under postmortem conditions, with the onset of rigor mortis, what happens is the denaturation of the proteins will be taking place because of the reduce in the pH. And since the denaturation take place, the water holding capacity of the muscles or the muscle proteins will be lost. So the water will be coming out of the muscle fibers. So that will lead to the shrinkage of the muscle fibers, and it leads to more space between the muscle fibers. This is what happening in the normal muscles. But in the case of DFT, what is happening is that since it is having a high ultimate pH, the denaturation of the protein will be less. Since the denaturation of the protein is less, the muscle will be having more water holding capacity. So this muscle fibers will be having more water holding capacity. So naturally it will be more swollen, and these muscle fibers are tightly packed with each other. So when the light falls, the reflection surface is less, so most of the light is absorbed, so it gives the dark color also. I'll repeat again. Since it is in the case of DFT, the ultimate pH is high, more than 6.5 or 6.3 like, okay, or 6.6 like. So at that high ultimate pH, the denaturation of the protein will be less. Since the denaturation of the protein is less, it will have more water holding capacity. Since it is having more water holding capacity, the muscle fibers are more swollen, and it will be tightly packed with each other. So there is no much surface for the reflections of the light. So most of the light will be absorbed, and it gives a dark color. So you can see here, because of the high ultimate pH, it is denaturation of the protein is less. Since the denaturation of the protein is less, it is having more water holding capacity. Since it is having more water holding capacity, the fibers are swollen and closed structure to form an intact muscles. So you can see here, this is in the normal muscles. We can see the ultimate pH is 5.4 to 5.6 will be the ultimate pH. So you can see here, less denaturation of the protein, more water holding capacity, fibers are swollen and closed structure of intact muscles. So here you can see the fluid is not coming out. So this is the normal, and this is the PFC, which we are going to discuss in the next lecture. So here you can see the fluid that comes out of the muscles is very less, but here you can see the fluid that comes is comparatively more in the normal muscles. So here it is having more water holding capacity, it is comparatively less water holding capacity because of the denaturation of the protein taking place due to reduction in the pH. Next problem, as we told with the DFT meat, is the spoilage, or the rate of spoilage we can see. So as we know that the glycogen content in the DFT meat is less. But the spoilage bacteria, especially if you take the major aerobic spoilage bacteria, that is Pseudomonas, or anaerobic spoilage bacteria like lactic acids bacteria. So most of the spoilage bacteria will first attach the glucose or the carbohydrate source. If the carbohydrate source is not available as the energy source for them, then it will start attacking the amino acids of the protein. So when it starts attacking the amino acids of the protein, there will be formation of ammonia and off odors will be there. So that will lead to the spoilage. Here again it's very interesting to note that the length of the lag phase is increased with decreased pH. When the pH decreases, the lag phase will be increased, so the rate of spoilage will be slowed down. So average glucose content of the DFT muscle is much lower than the normal muscles. So naturally the lag phase will be shorter and the log phase will be very rapid. So the expansional log phase, where the bacteria will be multiplying very fast, and that will lead to faster spoilage. So I'll repeat once again, in the DFT meat, the glycogen content is less. So you know the spoilage bacteria, first they will attack the carbohydrate source. If the carbohydrate source, sufficient carbohydrate source is not available, it will be acting on the amino acids of the protein. So when it acts on the amino acids of the protein, it can produce the ammonia and off odors will be formed. Here, since the glycogen content is less in the case of DFT meat, the bacteria will start attacking on the amino acids of the protein. And the lag phase will be short. In the lag phase, they will not multiply, but here the log phase will be faster. Naturally, the rate of spoilage will be faster in the case of DFT meat. Why DFT meat is not suitable for curing? Normally, what happens is when you apply the salt or the spices or the nitrates or nitrate, whatever the curing ingredients you add, the water comes out of the muscle or the meat. It will absorb the curing ingredients and it will be taken inside or it will be penetrated inside. So here what happens is, since it is having more water holding capacity, the water will not come out to absorb the spices, whatever we add, or the salt we add, or the nitrate we add, whatever you will add, it will not get absorbed inside because it is having more water holding capacity, so the water will not come out. Naturally, this meat will not taste, or we will not get that the flavors and the taste in this type of DFT meat. So here you can see the fiber of the meat is enlarged. It is having more water holding capacity. The penetration of the curing agent is also restricted, and the water will not come out to absorb the curing ingredients. So high pH also favor the microbial growth. That is why this is not suitable for making the cured products, or it is not suitable for making the curries and other things where the spices is added, because the spices will not be get absorbed inside the meat. So how to detect DFT meat? Already I told you, by the color we can see, and another simple by measuring the pH. Even after 12 to 48 hours, the pH will be more than 6. In such type of meat is DFT meat. So we can see here the normal meat, the meat with pH at 45 minutes will be around, after slaughter, when you check the pH of the meat, it will be around 6.4 in the normal meat. And the ultimate pH, say around 12 to 24 hours or 48 hours, we can say the ultimate pH will be around 5.5. In the case of DFT, even after 45 minutes, the pH will be around 6.4 or more than that. And the ultimate pH in the case of DFT meat, that is after 12 to 48 hours, if you check the pH, it will be more than 6. So this is how we can detect the DFT meat. So within 45 minutes, we'll be able to detect whether it is a DFT meat or not, or by using the color also we can detect it, the DFT meat or not. So thank you very much for listening this class. Take care, be safe.